Today we will discuss the chapter chemical kinetics, which is very important physical part of the chemistry book. So first we will know what is chemical kinetics or what this branch deals with. The branch of chemistry deals with the study of rates of reactions, the factors affecting the rates, and the mechanism by which the reactions take place or proceeds. The reaction proceeds. So this is the branch which is called chemical kinetics. So after studying this branch, we will able to know about the rate of reactions, the factors affecting the rates, and the mechanism by which the reactions are proceeding. Then based upon rates, different types of reactions are there, mainly three types. The first one is instantaneous reaction. They are also called as fast reactions because these reactions have very fast rate, or these reactions take place very rapidly. Within seconds the reactions get completed. Examples are, one of the most important example is, all neutralizer reactions are instantaneous reactions. Neutralizations means acids and base, acid-base reactions. When an acid is reacted with a base, we get a salt and water. In general, not always. Suppose an acid taken is HCl. This on treatment with NaOH, which is a very strong base, strong acid, strong base. We will get the salt NaCl, the eating salt, table salt, and water. This reaction is very rapid. The rate is very fast. So this is an instantaneous reaction. Another example is ionic reactions. All ionic reactions are instantaneous reaction. An example is, suppose silver nitrate is reacting with NaCl, provided all these are in aqueous solution state, dissolved in water, solid, liquid. These are also in dissolved state. We will get the silver chloride, a precipitate deposited at the bottom, and sodium nitrite. This reaction is also very fast and known as an instantaneous reaction. These reactions have a very fast rate because the reactions get completed very fast. Second type is slow reaction. The reactions which are not very fast are called slow reactions. These reactions have very slow rate. Slow reactions. An example is rusting of iron. When iron gets in contact with water and oxygen, it gets rusted. This reaction is very complicated, very complex reaction. Although we can write the simple reaction here, the simple reaction we can write here is, when iron comes in contact with water and oxygen, it gets rusted. It forms oxide. We can balance this reaction also. 4 iron, 4 Fe here. Here we can 6 and here 3. This is the complete balanced equation, rusting of iron. This is a very complex reaction, and the rate of the reaction is very slow, and this reaction takes longer time to get completed. Okay. The third type is moderate reaction. Moderate reactions. Moderate reactions means these reactions are neither very slow nor very fast. These reactions, the rate of these reactions comes under the slow reactions and fast reactions. And almost all known reactions are of this type. An example here is hydrolysis of ester. Suppose an ester is here is ethyl acetate, CH3 COC2H5, ethyl acetate or ethyl ethanoate. On treatment with water, or we can say acid hydrolysis, it forms acetic acid, CH3 COOH acetic acid or ethanoic acid, and ethanol alcohol. When an ester is treated with water, or we can say acid hydrolysis of an ester gives rise to an acid and an alcohol. And this reaction is neither very slow nor very fast. So this is a moderate reactions. Another example is hydrolysis of sucrose. Sucrose. The formula is C12H22O11. On hydrolysis, it gives glucose and fructose, C6H12O6 glucose and C6H12 fructose. Formula are same. This is also a moderate reaction. Okay, so these are the three types of reaction based upon the rates. These reactions are neither very slow nor very fast. Now, what is rate? What is rate of a reaction? The very important part, rate. Rate in the sense we can say it is the speed with which a reaction proceeds. Speed in the sense, actually what is a reaction? A reaction where the quantity of reactant gradually decreases and the quantity of products gradually form, we can say form, not increases, form. So rate means at which speed the quantity of reactants get decreased or the quantity of product gets formed. This is the rate. So suppose a reaction A forming product. So in a chemical reaction, the quantity of A or the concentration of A gradually decreases. Then you can see the rate is proceeding, the reaction is proceeding, and in the meanwhile, the quantity of product forms. So overall, in a reaction, this happens. So rate means at which speed the concentration of A is decreasing, or at which speed the quantity of the product is forming. Okay. And you should know that the rate is not uniform for a reaction. Suppose the initial concentration of A is A1, suppose A1 moles per liter concentration. After time t, its concentration becomes A2, and initial concentration of product is 0. Initially no product has been formed, so the concentration of product is 0, and after time t, some product has been formed. Suppose X amounts of product has formed. And you should know that whatever amount of the reactant has consumed is equal to the amount of the product formed. Suppose if X amount of reactant A is consumed or gets consumed, then the same X amount of the product will be formed, because whatever A is lost, that amount of B is formed. So here the quantity change, initial concentration of the or quantity of A was A and the final was A2. So the quantity change is A1 minus A2. This is the quantity change, and suppose this is X. Suppose if this is X, then X is the quantity of the product formed. So X is the product here. Okay. Now what is rate? Rate means at which rate. In order to calculate or know rate, we have to divide the concentration by time. Whenever we divide something by time, we get the rate or speed. Okay, so this is the quantity of the reactants lost, or this is the quantity of the product form. So the rate will be change. So we can say, we can write the definition of rate is equal to quantity or amount, quantity of reactant consumed divided by time taken, whatever in which time the quantity has been consumed. Or you can say quantity of product formed, quantity of product formed by time. Same things, whatever the quantity of reactant has been consumed, the same quantity of the product has been formed. Okay, so this is the form. So in general we can suppose a reaction A forming product B. So that expression will be, you can say change, quantity changed, whatever the change, so you can dA this is, and time interval suppose dt. Suppose this amount of concentration is there at t1 time and this is in t2 time, so dA by dt is the rate, quantity changed and time interval. Suppose dA is the concentration, sorry, A is the reactant and B is the product, so that expression will be dA by dt, or rate will be equal to dA by dt or dB by dt. Okay, we can write A product or B. So the rate expression will be, rate for the reaction will be d by dt, or we can write dB by dt. In a reaction, the concentration of A gradually changes or disappear, and the concentration of B is formed or appear. So since the concentration of A is decreased, we can give a negative sign here. You should know that the rate of a reaction is always positive, it can never be zero or never be negative. So I will say you the significance of negative sign here. Suppose the initial concentration of, this is initial concentration and this is final. Suppose before starting the reaction, before the start of the reaction, the initial concentration of A is suppose A1. Okay, and the product is 0 because product has not formed. After time t, the initial concentration, this is at time t1. At time t2, the concentration of A becomes A2, and the product, some products has formed at this point. Suppose that product is X, and suppose initial concentration is 5 moles per liter of A, and it becomes 3 moles after time t. 2 moles has decreased, changed each 2 moles, and the 2 mole of product has formed, so X is equal to 2 moles per liter. Okay, now you can calculate here the change in concentration of reactant. I can write A1 minus A2, or A2 minus, sorry, final versus initial, dA, that is equal to how much? 3 minus 5 or minus 2. Okay, and time interval is t2. Time interval is this, suppose this is at 0 time, this is after 5 minutes, so time interval is 5, t2 minus t1 5, so minus 2 by 5. Here the rate becomes negative, but we have known that the rate of reaction is never be negative, so the rate is always positive. Since rate is positive, we have to give negative sign. If I put this value here, then I will get minus of minus 2 by 5. So overall rate is 2 by 5. But in the product case, don't need to give negative sign because product is always increasing. Okay, the initial product was 0 and final product was 2. So final was 2 and the time is same 5. So product is, it is nothing given 2 by. Okay, I think you get the answer. Now we will study how we can write the rate expression of a reaction. Suppose a reaction is A plus B forming product C. So in this way we can write the rate of the reactions. Rate expression for this reaction will be minus of dA by dt is the dA is the change in concentration of reactant is equal to minus of dB by dt is equal to dC by dt. Okay, change in concentration of A by time interval is also the rate of a reaction. Also we can write rate of concentration of B by time interval also rate of the reaction. So the definition of rate is changed here. Rate can also be defined as the quantity of the reactant space, any one of the reactant spaces. If there are more than one reactant spaces, then you can say the concentration of any one of the reactant spaces changed per unit time, or any one of the product spaces formed per unit time. So the general definition of rate is quantity of, this is the exact definition, quantity of any one of the reactant species, any one of the reactant species changed per unit time, or quantity of any one of the product species formed, any one of the product species formed per unit time. This is the exact definition of rate. Okay, so the rate will be, and you should know, and you have to remember always, when the rate of, when rate is expressed in terms of reactant, a negative sign is given before the term, and when it is expressed in terms of product, no need to give negative sign because product is always increasing. Okay, now suppose here the number of moles of all the reactants and products are same, because 1 mole of A is reacting with 1 mole of B and the product form is 1 mole. Okay, if the number of moles of reactants and product are different, then what we will do then? Suppose 2 moles of A is treated with 1 mole of B and it forms the product C. This is the general equation. Okay, look at here. 1 mole of B is reacted with 2 moles of A, or 2 moles of A is reacting with 1 mole of B. So what you see here, the reacting power, look at the reacting power. 2 moles of A is reacting with 1 mole of B. So the reacting power of A is more. So we can say the rate of A is more, because 2 moles of A has the capacity or power to react with 1 mole of B. So the rate of the reacting power of A is more. Okay, so in this case we can't write the rate expression. So in this case we can't write the rate expression in this way. Okay, so here the rate expression will be, this is the rate of disappearance of A. Suppose the rate expression here, in general, let us write that expression in the above way. Rate what? Minus d A by dt is equal to minus of d B by dt, or dC by dt. This will be the rate expression according to the above procedure, but this is not the correct rate expression. Here are 2 moles of A at the rate of, you can say this as rate of disappearance, because it gradually decreasing, and this can okay, rate of formation. Okay, here the rate of disappearance of A is twice the rate of disappearance of A, or we can say the rate of formation of C. We can write here dA by dt. The rate of disappearance of A, disappear, it has been disappeared, negative sign is given, is twice the rate of disappearance of B. Got the point? Or twice the rate of formation of C. Got the point? So this is now this is the correct rate expression for the given reaction. Or in place, if we I can also write this as dA by dt is equal to minus of d by dt dc by dt. This is the correct rate expression for the given reaction. I am taking another example. Suppose 2 mole of A is reacting with 3 mole of B and it's forming 2 moles of C. So here look at 2 moles of A is reacting with 3 moles of B. So the rate of A and B are not the same. 2 moles of A has the capacity to react with 3 moles of B and it has the capacity to form 2 moles of C. So the expression will be what? A and B. So the expression will be minus of half dA by dt is equal to minus of 1 by 3 d b by dt is equal to half d c by dt. This is the right expression for the given reaction. Got the point? What you are looking here? 2 moles of A is reacting with 3 moles of B and it's forming 2 moles of C. So whatever the coefficient of the species in the red expression, it becomes 1 by 1 upon 2 moles of A. In the red expression, it becomes 1 upon 2 or half. 3 moles of B in the red expression, it becomes 1 by 3, and 2 moles of C, it becomes half. So 1 by 1 upon whatever the coefficient in the red expression in the reaction, in the balanced reaction, it becomes 1 by in the red expression. Got the point? So in the general sense, suppose A moles of A is reacting with B mole of B, and suppose the product is C mole of C and D mole of D. So the rate expression for the given reaction will be rate will be minus, since it is reactant, minus n is given, 1 upon A d A by dt minus of 1 by B d B by dt, that is equal to plus 1 by C dC by dt, that is equal to plus 1 by d dy. Whatever the coefficient, it becomes 1 upon in the rate expression. Okay, and this is the rate expression. You can write the rate expression for any reactions. Okay, then we will move towards the rate, types of rate. Actually, rate of a reaction is not uniform, because we know from the law of mass action, rate of a reaction is directly proportional to the molar concentration of reactant. Molar concentration of reactant. It directly depends upon the reactant, not on the product. So rate is dependent on product. It's a reactant. And we know the concentration of reactant gradually decreases in a reactions. So the rate will be decreased because rate is directly proportional to reactant. So in a reaction, rate as well as concentration gradually decreases. So the rate is not uniform. So in order to know or calculate the rate of a reaction, we have to consider the average rate. Average rate or instantaneous rate. Rates are further classified into two types: average rate and instantaneous rate. Average rate and instantaneous rate. So what is average rate? First, average rate two types because it is not uniform. First, average rate. Average rate. Average rate means we have known that if A is the reactant and B is the product, so the concentration change is, suppose the concentration change, suppose X amount, the change amount of H, suppose X, and the same amount X has formed. So the constant, so dx, so small amount of, sorry, delta x, del x is the amount of x change. Del x mean initial concentration of A and the final concentration of, suppose, A. Okay, so delta x, okay, delta A here also, no problem. Okay, so suppose the time, suppose A0 is the initial concentration at time 0 time, initial time where the reaction has not started, and A2 after some time, suppose 10 minutes, 20 minutes, so this is let 10 minutes or T1. So del T is equal to T1 minus 0 del D and del A. So the red expression will be del A by del D. This is the red expression. Okay, you have to know one thing here: instantaneous rate and average rate. Second is instantaneous. Instantaneous mean fast. Instantaneous mean at any instant the reaction can be completed, very small time interval. So when the time interval chosen is very small, when the time interval is very small, or we can say we are considering the reaction at a very small time interval, then we can say the rate of the reaction is instantaneous rate. And when the time interval is not small, or you can say it is large, then we can say we are calculating the average rate. When time interval is large, that is we can say del t. Del t means time interval is large. Time interval is large. So this is the average rate. In this case, we can get the average rate. And when the time interval is small, small means we can small d small dt, small time interval, small time interval. When small time interval is taken, we can calculate the instantaneous rate, and when the time interval is taken large, then we can find the average rate. One thing here you can know, you should know, for instantaneous reaction, the time interval chosen is so particular that at that point the reaction is supposed to be, the rate of the reaction is supposed to be almost constant. Okay, so for instantaneous rate, the time interval is very small, so dA by dt. And for average rate, the time interval should be large, so del A by del D. Okay, so this is about the types of rate. In the next part, we will discuss the rate expression. Now, one thing, what is the unit of rate? We know rate is nothing but the concentration of the reactant species consumed or the concentration of the product species formed per unit time. So overall rate is concentration per time. And we know the unit of concentration is moles per liter. Moles per liter. And the unit of time is either minute or second. Second is unit second. So the unit of rate is moles per liter per second, or moles per liter per minute also. Okay, so this is all about the rate. In the next class, in the next part, we will discuss about the rate expression. Okay, and also we will discuss the molecularity and order of a reaction. Thank you.